Good morning, class. This is pre-calculus practice test, module 3, covering chapters 5, 6, 7. Here's chapter 7, trigonometric equations and identities. Starting with finding the exact value of some inverse functions. Those are some common arcs. We don't need a calculator, so we want to find the tan inverse of tan of negative 2 pi over 3. So I want to quickly give you the synopsis of what you have seen as far as the inverse functions are concerned as follows. Sine inverse. By definition, when we write y equals sine inverse x, then x becomes sine y, where x is between negative 1 and 1, and y is between negative pi over 2 and pi over 2. If you recall, sinusoidal functions are not one-to-one, and with the restriction of negative pi over 2 to pi over 2 for their domain, we make them one-to-one, and this way they cover the whole range of negative 1 to 1. F inverse, if you remember, but it becomes x as long as it works out in the following manner. Sine inverse of sine x is x when x is between these two numbers, negative pi over 2 and pi over 2. Sine of sine inverse of x is x when x is between negative 1 and 1. Now, tangent basically follows sine, and we have the same restriction with the exception that in the case of a sine, equality is fine. In the case of a tangent, is not. If you recall, when we graph it, it creates vertical asymptotes. So the main difference is the equality doesn't exist. Otherwise, it pretty much follows the sine. Cosine, we go from 0 to pi. The restriction is such that all values of cosine must be covered, and that's why we go from 0 to pi instead. I hope you remember that each and every one of them is positive in the first quadrant. In the second quadrant, sine is positive, cosine is negative, and in the fourth quadrant, cosine is positive, sine is negative. Now, cosecant is equal to 1 over sine, so it follows the sine. And secant is 1 over cosine, and it follows cosine as far as the restriction, as you can see here, 0 to pi, 0 to pi. So with that being the case, when you have this, if it was within the given range, we would have negative 2 pi over 3, but that's not the case when it comes to this value. As you can see, negative 2 pi over 3, if we were to graph this starting from 0, when you go to negative 2 pi over 3, it puts us in the third quadrant. So first and foremost, the reference arc is pi over 3. So this is the same as tangent of pi over 3, which is square root of 3. Third quadrant, it's positive. You got to figure out the sign. And therefore, we end up with tan inverse of square root of 3. And now we know this is pi over 3 because tangent follows sine, and it has a restriction of negative pi over 2 to pi over 2. Secant inverse of square root of 2, we set this equal to some value, some angle, let it be alpha. And if you write it in this manner, by definition, then secant alpha must be square root of 2. Now, we may not be too familiar with secant, but we remember that secant is 1 over cosine. And the reason I mention that is if we have memorized the trigonometric functions of common arcs, so cosine is 1 over square root of 2 or square root of 2 over 2, which results in alpha being pi over 4. The reason we go from secant to cosine because we are supposed to know the common arcs for sine, cosine, tangent at the very least. And the rest of them, we can go with the reciprocal. Remember, 0, pi over 6. Pi over 3, pi over 2, that's basically dealing with the first quadrant, and those are some common arcs we should be familiar with, and we should be able to extend that to other quadrants. Cosine inverse of 1/2, what is it? We call it some angle, let's say alpha, beta, theta, you pick your choice. Therefore, cosine is equal to 1/2. Cosine of theta equals 1/2, and theta becomes pi over 3. Again, one of those common arcs. Tan of cosine inverse of square root of 3 over 2. In essence, cosine is given. We want to find tangent. So we let this one be represented by some angle. And since we've used alpha, theta, let's go with something like beta. By definition of inverse function, cosine beta becomes square root of 3 over 2. And therefore, beta becomes pi over 6. So we are looking to find tan of pi over 6. Tan of pi over 6 is square root of 3 over 3. Cosine of cosine inverse of 1.2. If it were within the proper range, the answer would be 1.2, but this is undefined because it has to be between -1 and 1. If you look at this piece and you set this equal to, let's say, gamma, cosine of gamma is 1.2. Let's do that, and there is no solution for that. So if you set cosine inverse of 1.2 equals, let's say, gamma, then by definition, cosine gamma equals 1.2. And cosine can only go from negative to positive. We want to find cosine of sine inverse of -1/3. In essence, if you set this equal to theta, you're looking for cosine of theta. That's the idea. Sine is given, find cosine. So first and foremost, we call this theta, and therefore we are looking for cosine of theta. So that's what we are looking for. There are a couple of different ways of approaching it. We can use the unit circle, or we can use triangles. I'm going to look at both ways. So you figure out which one is easier, you take it from there. So having said that, sine is -1/3, and we are dealing with sine inverse. Since theta must be between -pi/2 and pi/2, we recognize it has to be in quadrant 4. On the other hand, we remember that sine theta was y over r. If you recall, in a unit circle, x and y are represented by sine and cosine, such that x is, so if we have a pair x comma y, x is cosine, let's say t, y is sine t. So with that being the case, x becomes 2 square root of 2. This is in a unit circle, by the way, but it doesn't have to be unit circle as this is the case here. So why is that? Let's see the reason for that. X squared plus y squared equals 9. Why is that? Because r is 3. This is for the unit circle. This is when the circle is centered at 0, 0 with a different radius. X squared plus y squared equals 9. So with that being the case, if we are choosing this distance to be 1, of course, -1, that's why we are in the negative side. But as far as the distance is concerned, it is 1, and this is 3. So 3 squared becomes 9 minus 1 squared becomes 8, and it's square root of that. So in this formula, in essence, you have this number, you have this number, and you're going to find x. So x squared plus y squared equals 9. This is 1, so x squared equals 8. Now that we have that, we can answer this because we know cosine is x over r. Remember, in a unit circle, cosine is x. But if it's not a unit circle, it's x over r. So this is one way to do that if you want to use the circles. If you want to use the triangle or identities, in this case, let's see what happens with the identities. We mentioned, in this case, sine is given, and we want to find cosine. So Pythagorean identities, sine squared plus cosine squared equals 1. 1 plus tan squared is secant squared, and 1 plus cotangent squared is cosecant squared. I hope everybody's comfortable with that. So given sine, cosine becomes plus minus square root of 1 minus sine squared theta in general. This is a general case. We have to figure out the sine according to the quadrant. Now, we are in the fourth quadrant and cosine is positive. So 1 minus, now whatever sine is, square it. This becomes 1 over 9. 1 minus that becomes 8 over 9. And it becomes 2 square root of 2 over 3 because this comes out and this is simplified to 2 square root of 2 over 3. Either way is fine. By the way, it's important to know, if we know this formula, then you know sine squared is 1 minus cosine squared is 1 minus sine squared, or cosine is plus minus square root of 1 minus sine squared theta, so on and so forth. Many, many different formulas from that. Now, sine of tan inverse of u, where in essence tan is given and we want to find sine. So let tan inverse be represented by some angle. Therefore, by definition of an inverse function, tan theta becomes u. And we are interested in sine of theta. That's the process we are looking for. Now, we can use Pythagorean identities, and we know that there is a relationship between tangent and cotangent. They are reciprocal of each other. We know that 1 plus cotangent squared is cosecant squared, and from cosecant we get to sine, because they also have a reciprocal relationship. So one more time, because tan is given, we can go to cotangent. Because cotangent is given, we can go to cosecant. And from cosecant, after we find it, the reciprocal of that would be sine. So let's plug in, replace the cotangent with 1 over u. So when we square it, becomes 1 over u squared. It's cosecant squared. When we take a common denominator of u squared, we get the following. So this is cosecant squared. If this is cosecant squared, then what is sine squared? Reciprocal of this. Reciprocal of this. So that's sine squared. Therefore, sine is the square root of that plus minus. And we keep the plus. By the way, the u squared comes out simply because sine and tan have the same sign. Remember, we are going from the fourth quadrant from minus pi over 2 to pi over 2 in both cases. And both of them are positive in the first, negative in the fourth quadrant. This is one way to do that. Another way of doing that is to write the following. If you look at this triangular shape, tan theta by definition is the opposite over the adjacent. So this is a right triangle. So the opposite, so since this is u, you can say u over 1. The opposite is u, the adjacent is 1. So what is the hypotenuse? You have to square this one, add them up, put it under the radical. So the square root of 1 plus u squared, it's what's the hypotenuse? And we know sine is the opposite over the hypotenuse. And this happened to be, I think, a tad faster. So we looked at this from different points of view. If they ask you for a specific methodology, you follow. If not, you choose the one that works fastest for you. I want to remind you of some of the formulas. Sine of alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta. And you have a negative in between. Cosine alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta, so on and so forth. The same thing for tan of alpha plus beta. So we have the sum and difference formulas. The sum can give rise to the double angle. So if I choose this beta to be also alpha and extend this sine to alpha, is given to me as 2 sine alpha cosine alpha. If I do the same thing here, cosine alpha plus alpha, and I work it out, I get cosine to alpha, which is cosine squared minus sine squared. Now, if you replace the cosine squared by 1 minus sine squared, you get this formula. If you replace the sine squared by 1 minus cosine squared, you get this formula. So cosine to alpha can be represented by 3 different formulas. And it's important to know them because they are truly handy. Now, over here for tangent, if I change this beta to alpha, it gives rise to tan of 2 alpha. So I'm telling you how you arrive at the formulas. And in case you forget the formula, and you know some of the formulas, you can come up with the rest of them. And that's important to see how we arrive at those, because sometime later, if we forget, we can bring them up. So if we look at these formulas, forget about the first one. If you look at the second one, you can solve for sine squared and it gives you this one. If you use the third one, and that was cosine to alpha is 2 cosine squared alpha minus 1, then it can give you the next one that I'm going to come up with. But before I come up with that, take a look at this one. This formula, this one gives rise to this one. I hope everybody's clear. Now, if I cut the alpha in half, I have to cut the 2 alpha in half. So this is how you arrive at half angle formulas. Now for the cosine, if I use this formula, cosine to alpha is 2 cosine squared alpha minus 1. This formula gives us this. And now let 2 alpha be beta, for example. Then this becomes beta over 2 or alpha over 2, whatever you want to call that. And this gives rise to half angle formulas. In other words, this should help you remembering this. Now, of course, tan is in general sine over cosine. So this is the when you square it, just the ratio will give you the answer. The same thing for half angle. So sine of alpha over 2, cosine of alpha over 2, and tan of alpha over 2, basically you take a root of this column. It so happened in the case of a tan, again, you have a plus minus, you can develop it to become this. If you go inside the square root and you multiply the top and the bottom by one of them, 1 minus cosine alpha over 1 minus cosine alpha, or 1 plus cosine alpha over 1 plus cosine alpha, it gives rise to these two formulas. So again, I like to explain sort of how the formulas is arrived. So in case you forget, you can easily bring them up. We want to use the half angle formulas to give exact values. Sine of 195, it's half of 390, and 390 is the same as 30 degrees, right? Because you subtract 360 degrees or multiples of that. Now, it's important to know that it's plus minus that, okay? If we go with this formula. And now we figure out whether it's positive or negative. So 195 degrees is in the third quadrant where sine is negative. So you put both and then you make a decision. So it must be negative, class. So I hope everybody can see what happened. 390 over 2 is the same as 30 in essence. And 195 puts us in a quadrant where sine is negative, namely the third quadrant. Now, this is a common arc. We know the cosine value is square root of 3 over 2. So let's replace it. Now, if you multiply the top by 2 and the bottom by 2, then the bottom becomes 4, comes out as 2, and then 2 times 1 is 2 minus square root of 3. So let me just erase this in case it's hard to see that. Cosine of 15, 15 is the same as 30 over 2. We're going to use the formula. It's plus minus. 15 puts us in the first quadrant where everything is positive. So again, you start with plus minus, then you make a decision based on the quadrant. Again, I hope you realize you multiply this one by 2, the bottom by 2. 2 times 2 is 4, comes out as 2. And when you multiply by 2, becomes the same thing with the plus sign. It's a complex fraction you can easily handle. We want to prove the identities. Generally speaking, we start with the more complicated side. Although you can always start with any side and end up with the other one. Sometimes even they start from both sides and then they bring it to the same result. But the better course of action is to deal with one side and one side only. With that being the case, we're going to deal with the right-hand side, which is a more complicated side, and change the secant to cosine as follows. So we change this to 1 over cosine squared, 2 minus 1 over cosine squared. Complex fraction, multiply the top and the bottom. This is the fastest way to get rid of a complex fraction by LCD, which is cosine squared. When we do that, clearly the top just becomes 1, the bottom becomes 2 cosine squared minus 1. And we know 2 cosine squared minus 1 is cosine 2 theta. Remember that? Therefore, the answer is secant 2 theta by the identities we have learned. All right, again, we want to start with the more complicated side, the left side, and I hope you recognize this is a cubed plus b cubed. And it's an identity in algebra you should be comfortable with. So you just rewrite this accordingly. Follow this. A is sine, B is cosine. So sine theta, cosine theta is sine squared minus sine theta, cosine theta plus cosine squared. Now, clearly we can drop this. And you can see the answer, but you can move cosine squared next to sine squared to make it easier to see. So if you move this here, you see the sum of the two is 1. And this is the right-hand side. That's a proof. We want to solve this equation where sine 3 theta equals 1/2, and we choose to go from 0 to 2 pi only. So whenever you have multiple angles, if you want to come up with the correct answer, here's the process. First, I'm going to remind you if we had sine x equals 1/2, then sine equals 1/2 when x is pi over 6. Therefore, pi over 6 is the reference angle. Also, the second quadrant gives us positive, so 5 pi over 6. So there are two answers. End of this story. However, anytime you have a multiple angle, you want to follow it in the following manner. It's extremely important. So you come up with the answer here, and then you say 3 theta is pi over 6, and later on 5 pi over 6. So just deal with pi over 6. And you write down 3 theta is pi over 6 plus 2n pi. Therefore, theta is what? Divide both sides by 3. This is pi over 6 divided by 3 becomes pi over 18. 2n pi divided by 3. Now, replace the n with 0, 1, 2, but not 3. And you get to the answer. So if you replace it with 0, you get pi over 18. With 1, 13 pi over 18. With 2, 25 pi over 18. To make sure we understand why we are stopping at 2. If you use number 3, 3 and 3 cancel each other, this is 2 and pi. This is going to repeat itself, in essence becomes pi over 18 again. So if you choose, if you call this n, if you choose n, it's not going to work. So you want, let's say 1, 0, 1 all the way. If you call this n, n minus 1. You can even see that if you plug in 3, it goes beyond 1 revolution. So with that being the case, the second part is 5 pi over 6. We do the same thing again. Multiple angles. This is the way not to miss any of the answers. So 5 pi over 6, we're going to set that 3 theta as 5 pi over 6 plus 2n pi. We're going to divide both sides by number 3. We get this one. Replace the n with 0. You get this one, 1 and 2. And here's the answer. Therefore, in essence, we have a total of 6 answers. Pi over 18, 13 pi over 18, 25 pi over 18. 5 pi over 18, 17 pi over 18, 29 pi over 18. And you can always check it out. So we wanted the answer to be between 0 and 2 pi. In other words, this had 2 because this is 3. 3 times 2, the result has 6 answers. But I want you to pay attention to the methodology I've shown you here. This is the way to deal with multiple angles without missing anything. We want to solve the equation, and we notice that everything involves sine except the first one. So if we change this to also somehow involving sine, maybe we can do something about it. So we're going to change the cosine squared to 1 minus sine squared. And we're going to simplify by combining. If we treat this as a quadratic equation, we want to put it in descending order. So we're going to multiply everything by -1 and we put it in descending order. Meaning this becomes positive, both of them become negative. Now, if you have a hard time following what happens next, you can let sine x be y. Okay, you don't have to do that, but if you let y represent sine x, you're dealing with 2y squared minus y minus 1 equals. So you don't have to think about it that way. It's up to you if you want to make that substitution, if it makes life easier. Now, of course, it can easily be factored out. 2 is a prime number and -1 has to be 1 or -1 only. And you want the middle term end up being negative sine x. So this is minus 2 sine x, this is plus, so it works out. So there are two choices. Either sine x is -1/2 or +1. Now, when sine x is -1/2, first think about 1/2 and the reference angle is pi/6. Negative puts us in the third quadrant and the fourth quadrant for sine. So pi plus pi/6 and 2 pi minus pi/6. So I'm saying that if one way to understand this from here, the reference angle you should recognize is pi/6. Okay, so anytime you want to figure out the reference arc, you go to a positive value. And of course, you take it from there. Now, sine x equals 1, there's only one solution, which is pi/2. So let me just remind you quickly as far as, remember if this is theta of r, okay? So then in this, you are looking for the closest value when you're dealing with the 0 or pi for that matter. And because of that, if this is pi/6, and you know that for negative, we are in the third quadrant, and this is pi, therefore you are going to say pi in the third quadrant, pi plus pi/6. If we were looking for the second quadrant, it would be pi minus pi/6 as an example. And in the fourth quadrant, okay, we are looking at what? 2 pi minus pi/6. That's how you find it. In essence, I wanted to remind you of the reference arc aspect. We want to prove the following. Cosine of pi/2 plus x equals minus sine x. So again, let's remind everybody of the formulas we've learned, the sum formula. So we are going to go with cosine of alpha plus beta, cosine alpha, cosine beta. That I'm looking at the left-hand side. So cosine of pi/2, cosine x, minus sine pi/2 sine x. Now, we know cosine pi/2 is 0 and sine pi/2 is 1. Replace them. This goes to 0, this becomes negative. We want to prove this. Again, we start with the more complicated side, namely the left side, and we replace the tangent with sine over cosine, secant with 1 over cosine. And clearly, we can multiply both sides by cosine. So the top becomes a sine, the bottom becomes a 1. And that's the final answer. So a complex fraction can be taken care of easily. We want to prove this one again, starting with the left-hand side because it's more complicated. I hope you recognize that this can be factored into cosine squared plus sine squared times cosine squared minus sine squared. In other words, I'm looking for a squared minus b squared is a plus b times a minus b. That's what I'm using. And of course, everybody knows this is 1. This is equal to 1 because cosine squared or plus sine squared or sine squared plus cosine squared makes no difference. So the answer is the second parenthesis. And as you recall, this is cosine 2 theta. Because cosine 2 theta has several ways of writing it. One of them would be cosine squared minus sine squared. The other one is 1 minus 2 sine squared or 2 cosine squared minus 1. So cosine squared minus sine squared. We want to prove this one. Again, the left-hand side seems to be the right one to begin with. And the top is tan. We notice that 1 plus tan squared is secant squared. Because remember, we're going to get to the right somehow. We're going to replace the tangent with sine over cosine, and secant is 1 over cosine. So the bottom becomes 1 over cosine squared. Again, you're dealing with a complex fraction. The LCD would be cosine squared. Let's multiply the top and the bottom by cosine squared. When we multiply the top by cosine squared, this goes away. This becomes cosine times sine, so sine cosine, and the bottom just becomes 1. Sine x times cosine x divided by 1, we don't have to write it, which is the right-hand side, what we wanted to prove. We want to find the exact answer. 2 sine pi over 8 cosine pi over 8. We notice it follows sine of 2 alpha, which is 2 sine alpha cosine alpha. So we have the right side. It equals to the left side sine of 2 times pi over 8. So we are going this way. 2 times pi over 8 is pi over 4. Sine of pi over 4 is square root of 2 over 2. Everybody knows that. Well, although we can just plug in, we know sine of 45 and cosine of 45, each one to be square root of 2 over 2. However, if we stick with this, we are going from right to left, sine of 2 alpha. That means sine of 2 times 45 degrees, which means sine of 90 degrees, which is 1. We can use cosine of alpha plus beta formula, where 7 pi over 12 is 3 pi over 12 plus 4 pi over 12. This one, pi over 4. This one, pi over 3, both of which are common arcs. So let's go with cosine alpha, cosine beta, minus sine alpha, sine beta. This is what we get. We are going to replace them accordingly. Cosine of pi over 4, square root of 2 over 2. Cosine of pi over 3 is 1/2 minus sine, again, of pi over 4 is square root of 2 over 2. And sine of pi over 3 is square root of 3 over 2. Now, obviously, the denominator is 4 for both cases. So that's a common denominator. Square root of 2 times 1 gives us square root of 2 minus square root of 6. We may have different ways of approaching this stuff. I want you to know that. But we stick with what they ask. If they don't, you can come up with a method that may be different. All right, we want to answer this. And again, we are reminded of this formula. Cosine of alpha plus beta follows this formula. And cosine of alpha minus beta follows this formula. Therefore, because of the plus sign here, we have cosine of alpha minus beta. Here's alpha, here's beta. Cosine of alpha minus beta. So we get negative 4 pi over 12, which is negative pi over 3. This is which is the same as cosine of pi over 3, which is 1/2. So the negative remains, but remember, cosine of negative pi over 3 is the same as pi over 3, because cosine is positive in the fourth quadrant. Now we basically do the same thing. 105 degrees is the sum of 60 and 45 in any order you want. And we're going to expand it using cosine of alpha plus beta. So cosine 60, cosine 45, minus sine 60, sine 45. And we're going to replace them. They're all common arcs. Cosine of 60 is 1/2. Cosine of 45 is square root of 2 over 2, minus sine of 60 is square root of 3 over 2. Sine of 45 is square root of 2 over 2. We have a similar situation to the previous page. They all have the same denominator, namely 4. What is the numerator here? 1 times square root of 2, which is square root of 2, minus the product of these two is square root of 6. And we are done. In other words, cosine of 7 pi over 12 is the same as cosine of 105 degrees, because they are the same. One is in radians, one is in degrees. The point being just recognizing it. By the way, if you happen to have them in radians, you have a difficult time recognizing when you want to look at the sum and difference angle and half angle and so forth. You can go to degrees if it's easier that. Again, we are looking at the sum angle. So this is sine of alpha plus beta. Because we have a plus sign, it follows the first formula. So the first one is alpha, the second one is beta. Add up the two numbers, you get 60 degrees. Sine of 60 is square root of 3/2. (165 degrees). We can cut it into two pieces, 120 plus 45. And now develop it with this. Sine of 120 cosine of 45 plus cosine of 120 sine of 45. Now, remember, 120 puts us in the second quadrant. And the reference arc for that is 60 degrees. So it's the same as sine of 60 degrees. In the second quadrant, sine is positive. So the same as sine of 60 degrees, square root of 3/2 times cosine of 45 is square root of 2/2. Now this is the same as cosine of 60. However, in the second quadrant, cosine is negative. So we still have the same reference arc, but we have to pay attention to the quadrant. Cosine is negative there. So cosine of 60 is positive 1/2, but cosine of 120 becomes negative 1/2. Again, they all have the same denominator, namely 4. Multiply these two square root of 6, plus multiply these two with this negative minus square root of 2 in the numerator. So pay attention to the quadrant and so on and so forth. By the way, could we have done this with a half angle? This is 330 degrees divided by 2, which makes it a common arc. Also, you can play with that if you want. I highly recommend you try that. It's half of that, 330 divided by 2. Try that. All right, we want to prove the identities. In this case, we want to simplify this. We are going to multiply these two, which becomes a plus b times a minus b, a squared, secant squared, minus b squared, minus tan squared. Also, I'm going to remind you of Pythagorean identities. Look at the second one. 1 plus tan squared is secant squared. So if I move the tan squared to the other side, what do I get? Secant squared minus tan squared equals 1. So this is equal to ln 1, and ln 1 is 0. All right, we want to prove this. Again, we start with the more complicated side, namely left side. Let's square this. A plus b squared is a squared sine squared plus 2ab, 2 sine theta cosine theta, plus b squared or cosine squared theta. This one, sine squared minus 2 sine theta cosine theta plus cosine squared theta. So let's see what happens. So this one and this one, they cancel each other. We have 2 of this. And 2 of this. We factor the 2 out. We know sine squared plus cosine squared is 1. And that's a proof. Two cosine theta minus square root of 3 equals 0. We want to find the answers between 0 and 2 pi. Also, we want to find the general solutions. So I hope you realize I can take this number to the other side, divide by 2, cosine becomes square root of 3 over 2. From 0 to 2 pi, then square root of 3 over 2, theta becomes pi over 6 in the first quadrant. And 2 pi minus pi over 6 in the fourth quadrant. So in case, remember that cosine is positive in the first quadrant. And in the fourth quadrant, reference arc is pi over 6. And you come up with that 11 pi over 6 by saying 2 pi minus pi over 6. In case. And of course, 2n pi or 2k pi, depending upon the text, they may use 2k pi or 2n pi, and they may even write plus minus. In any event, if you go with k, k is an element of integers. And I hope you remember integers would be the following set: 0, 1, 2 to infinity, negative 1, negative 2 to negative infinity. We want to solve this equation. We notice this is of quadratic nature. Again, you have a choice. If you let this be, let's say, x, you have 2x squared minus x minus 1. You don't need to. You know how to factor. This 2 is a prime number, so you need 2 and 1. 2 cosine theta, this is negative 1. It's easy to come up with the answer. So cosine theta is negative 1/2 here, positive 1 here. When it's negative 1/2, let's go with 1/2, which gives us pi over 3 for cosine as a reference arc. This is theta sub r, reference arc. Now we want it to be negative. That takes us to the second quadrant. That means pi minus pi over 3. And then the third quadrant, pi plus pi over 3. As far as cosine theta being 1, that happens when it's 0. So 2 pi over 3, 4 pi over 3 when cosine is negative 1/2. So this is the reference arc. You use this reference arc to get to the answer in the second and third quadrant. Pi minus pi over 3 and pi plus pi over 3, that's how you arrive at it. So those are the answers. Fairly simple. By the way, in some instances, you may end up with a case such as, for example, cosine theta equals 2, and that means no solution. You may encounter that. I wanted you to be aware of that. We want to find the exact value of the expression and justify the answer where we are given 1 minus cosine squared 20 minus cosine squared 70. And so this brings us to the fact that 1 minus cosine squared is the same as sine squared. I want to make sure everybody remembers that It comes from Pythagorean identity, sine squared plus cosine squared is 1. So this is sine squared plus cosine squared equals 1. Whenever you have sine and cosine, such that the total angle is pi over 2 or 90 degrees, then they are considered co-function. So co-function or complementary angles are equal in the following manner. Sine becomes cosine, cosine becomes sine, tangent becomes cotangent, cotangent becomes tangent. In other words, this is 90 degrees, and if you call this alpha and you call this beta, alpha and beta are co-functions, and the sine of one is equal to the cosine of the other. And tangent of one is cotangent of the other. That's important to remember that. So with that being the case, then cosine 70 is the same as sine of 90 minus 70 according to this. So I can replace that with sine. They cancel each other and I get 0. And to remember this, just go with this, and it makes sense to you that sine of alpha is cosine of beta and vice versa. Tan of alpha is tan of cotangent of beta and vice versa. I need to erase this. I need this space. Now, cosine 70, cosine 20 minus sine 70, sine 20. Again, we are looking at cosine alpha, cosine beta minus sine alpha, sine beta, which is cosine of alpha plus beta. Add them up, which is cosine of 90, and we know it to be 0. Cosine of 90, and it is 0. Same thing, it follows for tangent is tan of alpha plus tan of beta over 1 minus tan of alpha, tan of beta. That is tan of the sum, alpha plus beta. So we are using this formula, and we're going to add 20 to 25, which gives us 45, and we know tan of 45 to be 1. We are interested in finding sine of cosine inverse 1/2 plus sine inverse 3/5. Please understand this is an angle, let's say alpha. There's another angle, meaning beta. So you're looking for sine of alpha plus beta, which is sine alpha cosine beta plus cosine alpha sine beta. In essence, that's what you have. So we let this one be alpha. By definition, cosine alpha is 1/2. And remember, it's in between 0 and pi. That's the restriction on the cosine. You set this one to be beta. And by definition, sine beta becomes 3/5, where it's between negative pi over 2 and pi over 2. And therefore, you're looking for sine of alpha plus beta equals sine alpha cosine beta plus cosine alpha sine beta. So when you look at this, you see that you have cosine alpha, you don't have sine alpha. You have sine beta, but you need cosine beta. That's the idea. And so when we have cosine, we can easily find sine using Pythagorean identities. Remember, sine squared plus cosine squared equals 1. Using that, sine is the square root of 1 minus cosine squared. Now, plus minus. This is plus minus. Why are we choosing a plus? Between 0 and pi, the first and the second quadrant, sign is positive. So 1 minus 1/4 becomes 3/4. So it's square root of 3 over 2. So pay attention to the quadrant. In this case, we do the same thing. Cosine is plus minus the square root of 1 minus sine squared. And the reason is positive because in the fourth quadrant and first quadrant, cosine is positive. So 1 minus 9 over 25. I hope you realize this becomes 16 over 25. 16 comes out as 4. 25 comes out as 5. So we're going to replace them accordingly. Sine of alpha, we have it, square root of 3 over 2. Cosine beta, we have it, 4/5. Cosine plus cosine alpha, we have it as 1/2. Sine beta, we have it as 3/5. And so I hope you see the denominator is the same. So we have a common denominator of 10. This gives us 4 square root of 3. This gives us 3. So 4 square root of 3 plus 3 over 10. That's a precise answer. No calculators. Establish identities. Again, the left-hand side is more complicated. We start with the left and replace the tangent with sine over cosine. Now, the common denominator is cosine theta times 1 plus sine theta. Sine theta times 1 plus sine theta plus cosine theta times cosine theta. If you want, I can write this at top of it just to be on the safe side. So this one gives us sine theta times 1 plus sine theta, which is this one. And then the second one gives us cosine times cosine. Now, obviously, sine squared plus cosine squared, they add up to 1. So the numerator, class, the numerator is sine theta plus 1. I hope you realize 1 plus sine theta or sine theta plus 1 makes no difference. They cancel each other. So the denominator is cosine theta. The numerator doesn't have anything, which means 1, and 1 over cosine is secant. 1 over cosine is secant. Again, the left-hand side is more complicated. We start with the left-hand side. We take a common denominator of sine, cosine. So this one, we have to multiply it by cosine minus, we're going to multiply this one by sine. So we are taking a common denominator, everybody. When we do that, we raise this by a factor of cosine, we raise this by a factor of sine. Now, notice sine of alpha minus beta. So sine of alpha cosine beta minus cosine alpha sine beta. I hope you realize the top, therefore, according to this formula, is sine of alpha minus beta. That means 3 theta minus theta. Also, notice this one. If we had a 2 here, 2 sine theta cosine theta would be sine of 2 theta, would be this formula if number 2 was here. So what is this? Half of that. So this is sine of 3 theta minus theta, which is sine of 2 theta. And this is half of that, which is also sine of 2 theta. So these two cancel each other. We get 1 over 1/2. 1 over 1/2 equals to 1 over 1/2 equals to 1 minus sine squared over 1 minus cosine theta equals minus cosine theta. Again, the left side is the more complicated side. There are different ways of approaching this. One easy way, change the sine squared to 1 minus cosine squared. And notice that the top is a product of 1 minus cosine and 1 plus cosine. Therefore, I can drop this easily and I get 1 minus the parentheses 1 plus cosine theta, which is 1 minus 1 minus cosine theta, which is negative cosine theta. And this is the fastest way. But when you do identities, sometimes there are other methods. So as an example, just for this one, you could have just taken a common denominator here. So 1 times 1 minus cosine theta goes at top. And you have cosine squared minus cosine theta because 1 and negative 1 cancel each other. And now if you factor out the cosine, these two are not identical. These two are opposites. So when you cancel them, it generates a negative sign. In other words, you could do this. You could say, I'm going to drop these two, and it gives me a sign negative, so negative cosine. Now, which one is easier? I'm not too sure. You decide. But I just wanted to mention that sometimes there are different approaches. As long as you are consistent, it's fine. Here's another example. Again, clearly the left side is more complicated. Sine theta plus cosine theta over sine theta minus cosine theta minus sine theta over cosine theta. We want to prove it's secant theta cosecant theta. So let's take a common denominator, which means this times this minus this times this goes in the numerator. The product of these two pieces is the new denominator in any order you want. There is a reason I changed it to cosine to sine. In a moment, you'll see it. Not that it matters. So clearly we can drop sine theta cosine theta with negative sine theta cosine theta. And the top is sine squared plus cosine squared or cosine squared plus sine squared, which is 1. Either way, in any order. So we separate it into 1 over cosine theta times 1 over sine theta. And that is secant times cosecant. And that is the proof, everybody.